Finding the area of lenses from diameter and chord length by Britton Stamps. Example problem. A circle has a diameter of 10 centimeters and a chord with the length of 8 centimeters. What is the area of the lens created by the chord? I will be working through this problem for the remainder of the video. I will be using a 5-step process that will effectively find us the area of the lens. Step 1. Find the radius of the circle and use it to create an isosceles triangle. The radius of a circle is equal to 1/2 that of its diameter. Since the diameter of this circle is 10 centimeters, the radius is 5 centimeters. In order to create the isosceles triangle, you create line segments from the center point of the circle to the endpoints of the chord. Since the endpoints of the chord are on the circle, the two line segments created are both radii. Since one radius in a circle is congruent to any other radius within the same circle, the line segments you created are both congruent. Since the length of the radius is not equal to the length of the chord, the triangle created is isosceles. Step 2. Perpendicularly bisect the chord and find the measure of the angle of the sector. Use a compass to perpendicularly bisect the chord. When the chord is perpendicularly bisected, the isosceles triangle created in the last step will be split into two congruent right triangles. These congruent right triangles will be used in order to find the measure of the angle of the sector. The measure of the angle of the sector is congruent to 2x. 1x is shown in the visual. To find 1x, use inverse sine and one of the right triangles. Once 1x is found, multiply 1x by 2 in order to find the measure of the angle of the sector. In this case, the measure of the angle of the sector is 106.26 degrees. Step 3. Find the area of the sector. The area of the sector is equal to the measure of the sector angle divided by 360 degrees multiplied by the area of the circle. The area of the circle in the example is 5 squared multiplied by pi. Since 5 squared is 25, the area of the circle in the example is 25 pi. The measure of the sector angle is 106.26 degrees. This was found in the last step. So, plugging this information into the equation gives us 23.182 centimeters squared for the area of the sector for the example. Step 4. Find the area of the isosceles triangle. To find the area of the isosceles triangle, we must find the area of each congruent right triangle made in step 2. In order to find the area of these triangles, we must take 1/2 their base times their height. In this instance, we do not know the height of the right triangles, so we must solve for it using Pythagorean theorem. Since we already know the hypotenuse and the base of the triangle, we must use c squared minus a squared equals b squared instead of the traditional a squared plus b squared equals c squared formula. In the example, I get 3 centimeters to be the height of the triangles. Now we can solve for the area of a single right triangle, using 1/2 base times height. In the example, I get 6 centimeters squared as the area of one right triangle. Then, since there are two congruent right triangles, I must multiply the area by 2, and I get 12 centimeters squared. Step 5. Solve for the area of the lens. The area of the lens plus the area of the triangle is equal to the area of the sector. So, the area of the triangle taken away from the area of the sector equals to the area of the lens. The area of the sector in the example is 23.182 centimeters squared. This was found in step 3. the area of the triangle is 12 centimeters squared, which is found in step 4. So, if you plug the given information into the equation, the area of the lens for the example is 11.182 centimeters squared. Using this 5-step process, you should be able to find the area of lenses from diameter and chord length. I have provided you with explanations and equations that will now allow you to effectively find the area of lenses. Thank you for watching my video.